I built the drill press of my dreams. It has exactly the specs, all the dimensioning and the solidity that I've always wanted from my hobbyist drill press that I've had forever and been very frustrated with. And I've done it for a fraction of a cost of what it would take to buy, full-on professional floor model drill press. So why can't it cut holes? This is where I need your help. I'm going to analyze some of the ways that it failed, and I really need some analysis here. It's a little bit beyond my engineering abilities. So hopefully you can help me. Or if you just want to laugh at me, then you can watch the video and get a laugh too. It's just not happening. So my journey towards making a drill press, or even thinking that I could make my own drill press, started with going on YouTube and looking at other people who had made it successfully. The best example of a build I found was a Japanese YouTuber and builder named JSK Kubo. I think I'm pronouncing his name wrong, but I've never heard it pronounced by anybody. So one of the things that impressed upon me that it was possible to create a rigid, powerful, and especially dimensionally accurate system was the way that he broke down all the adjustment methods, how the sort of drivetrain would work with a handle-based system, how it used industrial linear rods or sort of CNC equipment to create it, and then the rest was created by wood. Okay, so let's quickly take a look at what's going on. I've got it on the side. I would never operate it like this because it's to its side and it's a little bit awkward to go in there and do your drilling. But just to see the mechanics, this is the optimal view. So the heart of the machine is, the basic concept is taking a corded drill, mounting it, and putting it in a linear system that allows you it to travel up and down. Everything is based around these linear rails that are sort of used most commonly in CNC type stuff. So the travel of the drill, it rides on rail blocks. On that, it's got springs to replicate the action of a quill in a normal drill press. It's got a big handle up here that drives it up and down. And then when you move to the tray, it's the exact same thing. It's all riding on, hold on, I'll try and lift it up and down here. It's all riding on these linear rails, and it can travel up and down. And the main thing is that it maintains dimensionality and perpendicular motion with everything. There's lots of built-in adjustment here to get everything square, to get the table square to the linear rails, to get the drill bit square to the table. You can tilt this table. I built that in as well. So to sum up, the architecture of the whole thing is working. It's stiff enough. It can drive everything quite well. The foundation of it is there. But now I'm going to try and drill a few holes, and you'll see where it's failing. Okay, so let's drill a hole with it. I'm using, I think it's just over a 1/4 inch twist drill bit type. Let's turn it on. We'll raise the RPM. Hole is decent, but I was struggling. Okay, let's start with a piece of softwood, and I'll just go into the tip of the rim. Now, if you know anything about drilling, you know that a Forstner bit, it just takes a lot of force to, there's a lot of force, circular force, which I've just discovered is torque, and there's a lot of up and down. You really have to press down pretty hard. But the advantages of a Forstner bit are that you can do flat bottom holes. You can drill at angles really well. Okay, so now I'm gonna get it to sort of a mid-range RPM, and we'll see how it goes. Oh, just stalling. Come on, man. You know, it does it, but it was a struggle. It wasn't fun. Okay, so let's try going into this scrap piece of maple. Not expecting anything here at all. It's just not happening. Okay, so this looks like about a 1-inch Forstner bit. It's going at a 45-degree angle through plywood, which is really tough to get through. This, look at that. This is crazy. It's just an excellent test of the ability of a system to mimic a real drill press. The stiffness required and the force required, this is every force that you would want from a drill press is in play there. It has to be very stiff to maintain, to not be bouncing back and forth. It has to have power going this way, up and down, to be able to drive into that piece of plywood. It looks like Baltic birch. It's got glue and laminate, so it's difficult to get through. And also a Forstner bit, unless it's the most razor-sharp Forstner bit in the world, it's going to take a lot of force to get it through. Okay, so any engineers out there or anybody that builds woodworking machines on a regular basis, now is your time to shine. Now is when I need your help. From my own thoughts, I'm just comparing these two things. Now I can sort of do an A/B because now I have two different drill presses. Again, this is a $200. You know, this thing is still actually cheaper. It's for what it does. It's still actually cheaper than this. This is about $200 Ryobi, very much a hobbyist drill press. But it has those basic functions of a drill press. It has a big ass motor on it. It's got this, like a pillar system. I don't know what this system is called, but this can generate a lot of force. So let's look at two specific forces, and that's the only forces that I can really think of. And I just need someone to think outside the box a little bit, because I don't know if there's anything else that I'm not thinking of. This is all I can think of for now. So the forces I'm going to examine are just one is the sort of up-down force, like the downward force that you can generate. So this force versus this. And then we're just going to take a general look at torque. Torque is something I've only ever used, I've been lucky or whatever, but I've only ever used tools that had the right amount of torque, and I never really had serious problems torquing or just, getting drill bits to spin until this. And it was kind of confusing until I was like, is it torque? Is it like the rotational force? And now, of course, after a little bit of research, I understood how important torque is. So we'll just examine that too. But I have no way of measuring torque, so we'll have to do it in a sort of theoretical way. So let's look at up and down forces first. All right, so what I have here is just a bathroom scale. I'm not going to do a close-up of the number that I'm getting. You'll just have to trust me. But I am going to crank on this drill press. Let's see if I can do it from here. Yeah. Okay, hold on. Here we go. 0. Crank it. 149 pounds of pressure I just put in. And I was using the same amount of force I would use to put a Forstner bit through a piece of wood. Let's do it one more time. Yeah. Okay, boom. Forstner bit going in. 135. Okay, so between 130 and 150 is what I'm getting off this drill press. Now, how can I get that much force just off this weeny little handle? It makes really good use of force because the whole drivetrain, it's not coming from back here. It's not coming. All this force isn't coming from back here. It's all just being suspended, and you've got this vice-like mechanism right here. So I only weigh like 160 pounds. So actually, I put almost, just by turning this handle, I've put almost my entire weight into this, just up and down force. So it's a decent amount, you know what I mean? It's like, that's if you were using a hand drill and you were fully just doing like a handstand on it, like putting your full weight, depending on how much you weigh, of course. But with larger levers, yeah, you can get more. But generally that's how much force I need to drive the sort of target Forstner bits that I'm using. Okay, so now I'm going to take the same bathroom scale and I'm going to go over to this machine and try it. Hold on, let me get this set up. Let's go right in the middle. $53.5. Okay, so I just got 53 pounds of pressure, and I had a good amount of crank. I don't want to go so hard that it's like, I still don't know what's going to happen to this. But yeah, anyway, so 53 pounds. So it's about a third of what I'm getting off the drill press, right? So we've got a third of the up and down pressure from this system. Now let's take a look at like a third factor just to second guess everything. So this is Milwaukee drill driver, 1/2 inch. The specs say this can produce 500 inch-pounds of torque. I don't know what the torque is on this. I've never been able to find that. And I've never been able to find the torque on this, but I'm assuming since it's stalling, it's less. But I could find it very easily on this. So this is 500. Now I have been able to drill using Forstner bits, using a good amount of force into a piece of wood. I just did it a few minutes ago, and I'm going to measure that force. I'm just going to simulate it here. Okay, so I'm putting about the same amount of pressure that I would do. So that's 48 pounds. So these are actually equivalent in just my normal up and down motion. These are equivalent. But what I'm assuming is not equivalent is torque. And I'm gonna go upstairs to my computer and I'm gonna look at torque a little bit more carefully. So I sat down at the computer to examine the torque specs of all the drills that were in play. I did manage to finally find the torque specs for the DeWalt drill that is in the drill press. The website said that it's 400 inch-pounds, which sounds like complete horseshit to me. It did not display those characteristics whatsoever. The Milwaukee drill that I use as a hand drill that can achieve what I need is 500 inch-pounds of torque. Most surprisingly, the drill that JSK uses, which is a 7-amp Metabu drill, or at least it's the equivalent of it by the same company, only has a torque of just over 100 inch-pounds. There are higher-end models that have more torque, but the version he's using only really has probably about as much torque as the drill I'm using. So I'm actually pretty close to calling bullshit on his whole build. Unless he's doing some kind of magic, I don't know how this drill is producing the amount of torque needed to drive a Forstner bit through plywood at an angle. Very confusing. I think I've got a good thing going here. Everything works. There's good stiffness to it. I think I've got all the infrastructure to make it happen, but I just need to make a few more moves, and I want to make the best educated guess that I can as to what the most successful move that I could make, because this could just be a great workhorse for the future and would really allow me to take the accuracy of my drilling and hole making, tenon making, etc. to the next level. So yes, I need help. Any suggestions, please? If it jumps out at you, just please leave them in the comments. If you just want to keep laughing at me and my failure, then you can do that too. Thank you for watching, and hopefully you can help. Okay. All right. Bye-bye.